Hey guys, welcome to part 2 of this series where we're going to add additional RGB LEDs to our MyColor system in S197 Ford Mustang. So in the first part, we quickly went over why we need to understand how does the RGB LED system work. It is, just a reminder, it is a common cathode controller setup. And I opted to use a common anode LED because of the way it is. Once again, we have our unlock and lock switch here. It is wired to a ribbon cable, which makes it easy for access in and out of the actual housing, and the resistors are downstream here inside the wire, and this is all pre-done from the factory. So our dilemma lies in how do we control a common anode LED with a common cathode controller system. And to do that, we need to whip up a mini circuit board, which utilizes transistors in order to create a linkage between the signal that comes from the common cathode controller and the grounds that are in the common anode LED. So I'm going to bring our diagram back here, and I'm going to just quickly explain this to you. Think of transistors as like mini drawbridges. You can control those drawbridges by means of applying a voltage. So if we have a common anode LED, we need to control these. What we can do is we can put transistors in here, one transistor in each, and the way we can open and close this is we take this signal, and when we want blue to open here, we reroute this. Instead of going directly to the LED because it can't, we're going to take this signal and we're going to put it on the drawbridge here. So every time this voltage gets applied, this opens and allows the current to flow. And then we do the same for the green and the same for the red. That allows the controller, which is going to control your input voltages, to actually open and close the grounds on your common anode LED. So what you see here is a box that I made, and I'm going to zoom out just a hair so we can see it a little better. There's many different ways to build this. There's many different ways to do it. I chose this because these boxes come with a solderable circuit board and kind of all of the hardware you need in order to turn it into something that's protected, right? So I'll provide you guys with a circuit diagram for this, but I'm going to essentially show you what this is, how it is set up. So now this is all unscrewed. I have the screws off to the side. I wanted to make this a little smooth for you guys. If you look here, you can see this little circuit. This is what I made. Each one of these is the transistors, and I've tried to color code red, green, blue, how you can see how this works. Now, this isn't the simple part of it. It's not just one thing. What I tried to do was make it a little organized. So you'll see this side is like this, and the back side has the other wires. Now, how I set this up is there is an input voltage and a ground here. That's 2 pins, voltage, ground. On this side, there's three pins. 1 pin for the red signal, which is over here, 1 pin for the green signal, 1 pin for the blue signal. Those are the ones that are going to come from the car, right? You're going to link into the MyColor LED system. You're going to divert the signal, or really kind of duplicate the signal and send it into this box. And over here is where we'll plug in. Now I made this so that you can plug in 2 separate LEDs, and the reason I did that is because I wanted to keep each one of these boxes self-contained. I really didn't want to be running things in and out of the door, in and out of the well, really it's just the doors that were going to be a headache because of the way you have the connectors sealing right where it goes in and out of the cabin into the door. So what we're ultimately going to do in this is we're going to get into the RGB signal here from the map pocket light in the door. This positive and negative, we're actually going to take that directly from the lock switch, because your lock switch actually has an LED already in it, right? The standard ice blue. So we only want this turning on when the normal light would turn on and off in the lock. So we're going to take the power that would have been going to the LED, divert it here. We're going to take the ground from that LED and divert it here. So now we're staying self-contained in the door for the RGB signal and the power. And on this side, the reason I put two is because one here is for the window switch and one here is for the locks. And those are the two other lights that are in the door. So this controller, I'll have the schematic up for you guys. I'm not going to go through how to make it, how to do the soldering. I've built 4 of these at this point. You know, some better than the rest. This is probably the best one, the cleanest version of it. But ultimately, you guys will be able to see the schematic and how to build it. If you really need help, you can obviously reach out to me. The reason I like this box is because, again, I added all these components. These don't come with it, but the box itself does. I did have to cut these holes in this in order to fit these through, but actually once you do that, it fits kind of nicely. I'm not that great at cutting the holes. You can see I drilled a hole with a power drill, and then I used a file to try to, you know, expand it, but sometimes I went too far one way, sometimes I went too far the other. So again, not perfect, but good enough to get the job done. So you put those 2 pieces on the sides, you slide it in. Now I'm not going to screw this together on camera, but it does come with screws, 4 screws to hold the board in place inside. And then you have your back cover, which you'll put on. And then you have 4 of these screws to hold it all together. Okay, so that's your box. Now I'll show you, here's the switch. And then what I did was I crimped on a JST connector, right? Because these are JST connectors as well. So I just crimped it on, and you can see here, it's crimped into the wires. I put some black electrical tape to hide the butt connectors, crimp butt connectors, but all you have to do now is take this, plug it in here, and that's it. Now, obviously, once we get in the car, we'll plug in this piece, we'll plug in this one, and then, you know, this is the door lock. We would have another one for the window switch that would plug in here. And again, it's all self-contained within the door. You don't have to run anything in and out of the door. You do all this, you get one door done, boom, you're good to go. Okay, so again, I'm not going to go over how to build this schematic. I may do that in another video and link to that, but that one will be a long one because it's going to take time to do all the soldering, to do all of the running of the wires. I use crazy glue to get it all clean, right? The wires are not loose. They're actually glued to the board so that they don't fly all over the place. And that will kind of take us to the end of this video. In the next part, I'm actually going to take you guys through how are we going to get the power, how are we going to get the RGB signal, because I personally don't like hacking into my car. I don't like putting splices on my wires. So what we're going to do in the next video is we're going to create what I think is called interconnect. They're called interconnect harnesses. And what the harness does is essentially, if you have 2 plugs, you will unplug them, spread them to here, and then you'll make your own harness that fits in between. And then you can divert off that. That means in case you ever feel like you mess something up, you just boom, boom, take that out, plug your old wires back in, and everything's good to go. So we're going to go over that in the next video. And if you guys are still with me, we'll learn how to do that. All right. Hope you have a good one.